Now we are going to solve the sixth problem in chapter 8 Heat and Thermodynamics. I will read the problem. A man starts bicycling in the morning at a temperature around 25 degrees Celsius. He checked the pressure of the tire, which is equal to be 500 kilopascal. Afternoon he found that the absolute pressure in the tire is increased to 520 kilopascal. By assuming the expansion of the tire is negligible, what is the temperature of the tire at afternoon? Very simple problem, we will solve it. First you have to understand that the factors which are to be taken here. In the morning, the temperature was T1 is equal to 25 degree Celsius. That must be written. That 25 degree Celsius, that should be converted into Kelvin. 273. By adding 273, you will get 298 Kelvin. So during morning session, the temperature is 298 Kelvin. By the time the pressure of the air inside the tire is 500 kilopascal, that is nothing but 500 into 10 to the power of 3 Pascal. Okay. Now the temperature, it is increased in the afternoon session, but we don't know the temperature in the afternoon. T2 must be found out. The pressure in the afternoon is how much? 520 kilopascal. So the pressure in the afternoon is given 520 kilopascal, 520 into 10 to the power of 3 Pascal. So you are asked to find out the temperature in the afternoon. Here, when the pressure is increased due to increase in temperature, we have to assume that the volume, there is no considerable change in the volume. Therefore, V1, that is volume of the tire in the morning, that should be taken as equal to volume of the tire in the afternoon. Both can be taken as V. There is no much change in the volume. Such kind of assumption must be taken into account. We know the fundamental formula, PV is equal to NKT. PV is equal to NKT is the fundamental formula here. PV is equal to NKT. So by using this simple expression, we are able to solve the problem. So we'll write the equation. For the morning, we can write one equation. For morning, we can write one equation. For afternoon, we can write one equation. P1 V1 is equal to NK T1 can be written. This is for morning. For afternoon, P2 V2 is equal to NK T2. So now the equation 1, that is to be divided by equation 2. So how will you do this? P1 V1 divided by P2 V2 is equal to NKT1 divided by NKT2. Here all are constants. Here V1 and V2 both are equal to V. Therefore, V1 V2 can be cancelled. NK can be cancelled. So the remaining part of the formula is P1 divided by P2 is equal to T1 divided by T2. What is required? T2 is required. So get the formula for T2. T2 is equal to cross multiply this P2 T1 divided by P1. So the formula is arrived out. Now we have to substitute the values. We have to substitute the known values. We know the value of P2, clear, and then P1, T1, everything is known. So let's substitute the values. Here, substitute the value. P2 is equal to 520 into 10 to the power of 3 into T1. T1 is already calculated, 298 Kelvin, whole divided by P2. P2 value is 520 and P1, here P1 must be written. So P1 value is 500 into 10 to the power of 3. Cancel both. After simplification, you will get the answer as, if you multiply the numerator, you will get 15490. 15490 divided by 500. After simplification, you will get 309.92. 309.92 Kelvin. So the temperature obtained, it is in the form of Kelvin. That is to be converted into degree Celsius. 309.92 minus 273 is equal to, after subtraction you will get 36.92 degree Celsius. 36.92 degree Celsius you will get. So in the afternoon, the temperature would be 36.92 degree Celsius. By the time the pressure of the tire, pressure inside the tire will be 520 kilopascal. Okay, very simple problem. The formula which is required to solve the problem is very fundamental formula, PV is equal to NKT. Okay.